a rock is moving through space, and if its path crosses Earth at the wrong moment, there may be nothing beneath it that survives unchanged. For most of human history, that threat was unavoidable. Today, for the first time, we have begun learning how to push back. The evidence of what these objects can do is already carved into Earth. In Arizona, meteor crater was blasted open about 50,000 years ago by an iron asteroid only a few dozen meters across. It left a crater more than a kilometer wide. Yet that impact was tiny compared with Chicxulub, the collision 66 million years ago that triggered global environmental collapse and helped wipe out roughly 3/4 of Earth's species. But the same objects that can destroy life also carry something unexpected: pieces of the world that existed before Earth. A meteorite may look like an ordinary dark stone, but some contain primitive minerals formed during the solar system's earliest history. Around 4.567 billion years ago, the young sun was surrounded by gas and dust. Grains collided, became larger bodies, and eventually formed planetesimals. Those planetesimals smashed together again and again until planets emerged. Earth itself was built through collisions. Not every fragment became part of a planet. Many survived as asteroids, preserving ancient chemistry almost unchanged. That makes them dangerous relics, but also scientific time capsules. Inside them, scientists can read a chemical record that survived from before the planets existed, preserving clues about the materials, temperatures, and reactions that shaped the earliest solar system itself. And the danger is not merely prehistoric. In 2013, an asteroid about 20 meters across entered the atmosphere above Chelyabinsk, Russia, and exploded in the air. The shockwave shattered windows, damaged buildings, and injured hundreds of people. It had approached from near the direction of the sun, making it difficult to detect beforehand. That event exposed an uncomfortable truth. We cannot defend Earth from an object we never see coming. So telescopes around the world repeatedly scan the sky, searching for near-Earth objects and refining their orbits. One famous example is Apophis. Early observations briefly raised fears of a future collision. More measurements removed that danger. On April 13, 2029, Apophis will pass safely about 32,000 kilometers above Earth's surface, close enough for our planet's gravity to alter its orbit. And that reveals the key to planetary defense. An asteroid does not have to be destroyed. If discovered early enough, it only needs a tiny change in velocity. Given years of travel, that tiny change can turn a direct hit into a clean miss. NASA tested that idea with DART. Its target was Dimorphos, a small moon orbiting the larger asteroid Didymos. Neither threatened Earth. That made them a safe laboratory. On September 26, 2022, DART approached Dimorphos at more than 6 kilometers per second. During the final moments, the spacecraft had to guide itself. Dimorphos grew from a point of light into a landscape covered with boulders. There was no landing, no braking. Success meant destruction. DART struck the asteroid. The collision shortened Dimorphos's orbit around Didymos by about 33 minutes. Debris blasted into space, forming an enormous plume and a comet-like tail. That escaping material provided additional recoil, strengthening the push beyond the spacecraft's impact alone. Humanity had deliberately changed the motion of a natural object in space. But to reliably deflect future threats, scientists need to understand what asteroids are actually made of. Some are solid. Others are porous rubble piles that respond very differently when struck. That is why missions such as Japan's Hayabusa 2 matter. It returned about 5.4 grams of material from Ryugu, a primitive, carbon-rich asteroid. The samples contain evidence of water-related minerals and abundant organic material. NASA's OSIRIS-REx mission brought material from Bennu back to Earth in 2023. Studies have revealed an extraordinary mixture of ancient solar system material, organic matter, and minerals altered by water. None of this proves that asteroids created life, but it exposes the great contradiction at the center of their story. Young Earth endured enormous numbers of impacts. Those collisions brought destruction and heat. Yet asteroids may also have delivered water-bearing minerals, carbon-rich compounds, and ingredients useful for prebiotic chemistry. The same process that can end ecosystems may have helped prepare a world where ecosystems could begin. Now, the story is continuing, with ESA's Hera mission. Launched after DART, Hera is traveling to the Didymos system and is expected to arrive in 2026. It will examine Dimorphos closely, measuring the aftermath of humanity's first asteroid deflection experiment. For billions of years, collisions have shaped everything around us. They assembled planets, altered worlds, transported ancient chemistry, and erased entire branches of life. They are creation and destruction, written in the same language. Earth is not suddenly safe. Planetary defense still depends on finding dangerous objects early enough. But something fundamental has changed. For the first time, a species born from a collision-built world has looked into space, identified the ancient threat, and proved that the next collision does not always have to happen.